Hello everyone, my name is Jyoti. I'm a CCNA and CCNP corporate trainer. I'm going to discuss a topic from CCNA, that is NAT, Network Address Translation. So, as the name says, Network Address Translation, it is a mechanism to translate IP addresses. For example, private IPs into public IPs and vice versa. And this is done in order to provide internet access to the users in a private network without wasting much of IP version 4 addresses. So we will discuss more about NAT, including the introduction and some detailed concept about NAT. But before that, let's discuss the content that we are going to cover in this video. So we are going to discuss first briefly about private and public IP version 4 addresses. Then NAT and PAT, in which we will discuss what is NAT, why do we need NAT, types of NAT, how it works, and at the end we will do the configurations. So let's start with public and private IP addresses. So public IP address. A public IP address is an address that can be accessed over the internet. For example, a postal address that is used to deliver a postal mail to your home is unique. Similarly, a public IP address is globally unique IP address that is assigned to the computing devices. For example, a web server, an email server, or any server which is directly accessible from the internet are the candidate for a public IP address. Then comes the private IPs. Private IP addresses, on the other hand, is used to assign to the computing devices within your private space without letting them directly expose to the internet. So, for the organizations to create their own private networks, private IPs are used. Like the computers, tablets, smartphones, which are sitting behind your home, or personal computers within an organization are usually assigned private IPs. They are not allowed to directly access internet. To do so, to allow access to the internet to the hosts which are using private IPs, NAT should be used. Now the public and private IP ranges in IP version 4 are, as we know, we have class A, B and C. Out of the 5 classes, class A, B and C are available to be used, and out of which they are divided as private IPs and public IPs. So the private IP range from class A is 10.0.0.0 to 10.255.255.255, whereas rest from 0 to 126 in the first octet value are the public IPs. Similarly, for class B, 172.16.0.0 to 172.31.255.255 is the private IP range. Rest from the 128 to 191 in the first octet value are public IPs. Similarly, in class C, 192.168.0.0 to 192.168.255.255 is the private IP range, and rest from 192 to 223 as the first octet value are public IPs. So let's discuss what is NAT. NAT is a mechanism to translate private IPs into public IPs and vice versa. So actually, NAT is a method of remapping one IP address into another by modifying network address information inside the IP packet header. So it became an essential tool in conserving global address space allocation because there was a need to find a solution for IP version 4 address shortage. As when internet started to grow fast, the IP version 4 addresses started to become short, and the problem was realized that the IP version 4 address will be exhausted. So NAT came as a solution. So NAT is also defined in RFC as 3022. It allows hosts that does not have a valid registered globally unique IP address, which is a public IP address, to communicate with other hosts through the internet. So NAT use a valid registered IP address to represent the private address to the rest of the internet. It changed the private IP address to publicly registered IP address inside each IP packet. Now, as we discuss the IP version 4 addresses as private IPs and public IPs, now comes the need for NAT. So first thing is it is used to access internet. Then, as we discussed IP version 4 addresses, now brief overview of the number of IP version 4 addresses is there are approximately 4.2 billion addresses in total in IP version 4, whereas the available IP version 4 addresses are only around 2.8 billion addresses. Rest are reserved for various purposes like scientific purposes, multicast, loopback, and we are left with only 2.8 billion addresses approximately, which are not enough to be used by every device. So, as the solution to the shortage of IP version 4 addresses, NAT came. There are some other solutions as well like CIDR, IP version 6. So, the question came that why do we need NAT if we simply can assign a public IP address to the host to access internet? So as you can see, because there are not enough IP version 4 addresses, there are only limited number of addresses available, and the internet started to grow faster. The problem of IP version 4 exhaustion was realized, and public IP addresses which are unique addresses are globally unique addresses. So it was not possible for every device connected to the internet can be assigned public IP address, and private IPs are not allowed to be routable over internet, but the need for private IP addresses to be unique is only within the private network. So NAT came as a solution. Then the types of addresses in NAT are inside local. The addresses of the inside hosts as seen from the inside, actually the private IP addresses are called inside local addresses. Inside global addresses are the addresses of the inside host as seen from the outside, which are the public IP addresses registered from ISP. Outside local addresses, the addresses of the outside host as seen from inside from within their network. Outside global addresses are the addresses of the outside hosts as seen from the outside. So as you can see in this diagram, this is divided as inside and outside network. Inside network is the local network, also called the private network. Outside network is the internet, that is the public network. So here you can see the inside local addresses, inside global, and outside local addresses, as we just discussed. So now how it works. So as you can see here, the inside network and outside network, and there is a Cisco router which is the edge router where NAT is configured, and this has to be noted that NAT is always configured on edge router. So how it works, let us assume that NAT is configured here on the Cisco router, as it is the edge router and NAT is configured on the edge router only. So when a request comes from the local user from the private network for a web server here, which is the outside local web server, so the request comes from the inside local host and is received by the Cisco router. It will translate it into the inside global address and it will forward it to the web server. And when the web server will reply back, the reply will be received by the Cisco router and it will translate it back. The destination IP address will be translated this time to the inside local address, which is the actual private IP address of the local host. And this is how it will be reached to the PC. So this is how NAT works. Then types of NAT. So there are three types of NAT: static NAT, dynamic NAT, and PAT or NAT overload. So static NAT is one-to-one mapping between a private IP address and a static public IP address. Dynamic is many-to-many mapping. A router will maintain a list of public IP addresses and the private IP addresses or the hosts using the private IP addresses will be translated into public IP addresses from this list, and this is called many-to-many mapping. PAT, which is called port address translation or NAT overload, is many-to-one mapping. It is the most common way of performing NAT through overloading. There are the multiple internal IP addresses are mapped into a single public IP address, but they are assigned with a different port number. So a unique port number is assigned to every internal IP address. So this is how they are identified. So some more detail about static NAT, that with static NAT you must register one IP address for every machine that you want to connect to the internet. So this approach isn't very useful because this is not a solution, not a good solution for saving the registered IP addresses. So this is one-to-one mapping between private IP address and static public IP addresses. Second, dynamic NAT. So dynamic NAT, with dynamic NAT, a NAT router maintains a list of registered public IP addresses. Every time an internal client tries to access internet, the router maps it to one of the registered IP address from the list which is currently available. So as a result, you need to register IP addresses only for the number of concurrent internet users. Then NAT overload or PAT. With this type of NAT, a router, which is the NAT router, has only one registered IP address, and the NAT router maps each internal client that needs to communicate with internet to a different port number from the registered IP address. So by using the same public IP address, which is the inside global IP address, a unique port number which is given to each client by the NAT router, the request when received from the internet or from the outside host, this is how the NAT router will identify that it has to be sent to which client. So this is how it works. Then for NAT overload, let's take an example. Let's take internal addresses we have are 10.0.0.1, 10.0.0.2, 10.0.0.3 and 10.0.0.4. So these are the four hosts using different private IP addresses and they want to access internet. So every client when will reach to the NAT router, when they send any request, will be received by the NAT router. It will translate it into a single public IP address which is the same for all. So let's say here the public IP address, the same public IP address is 14.1.23.5. So every host from 10.0.0.1 to 10.0.0.4 will be translated into the same public IP address 14.1.23.5 as you can see here, but will be given a different port number by the NAT router. Like host 10.0.0.1 is translated into 14.1.23.5 but given a port number 62450. Second time, when 10.0.0.2 sends a request for the web server or any public server, it will be translated into the same public IP address 14.1.23.5 but will be given a different port number, for example 62451. So this is how, by using a same public IP address but different port numbers, they are identified, and this is how NAT works or NAT overload works. Now the configurations. So in static NAT, as you can see, this is the diagram for the lab that we are going to configure. Here is one host which is the private host using IP address 192.168.1.1. Then there is the edge router where we will configure NAT. Their ISP router, which is the public router, the ISP router, and their public host, which is a server or a web server. So these are the commands that we will configure on the edge router. So first we will configure on the interfaces. Here on interface fast Ethernet 0x0, we will configure IP NAT inside, which is the interface where the traffic is coming in. Then on the interface serial 1x0, which is the outside interface, we will configure IP NAT outside where the traffic will exit. So the command to configure static NAT is IP NAT inside source static, then the private IP address that you want to translate here, which is 192.168.1.1, then the inside global IP address, the public IP address in which you want to translate your inside local address, which is 200.0.0.5. So after configuring this, we will use the verification commands to verify So the verification commands are show IP NAT translations and show IP NAT statistics. Now let's see how it works. So in GNS, I have configured this topology. I have given IP addresses to the hosts in the same scenario, and for routing I have given static routing here so that we can configure NAT and see the output. So let's go on the edge router to configure NAT. So here, first, as we discussed, we have to configure the interfaces with IP NAT inside and IP NAT outside. So here, interface fast Ethernet 0x0 will be configured as, you can see here, it is IP NAT inside. Then on the interface serial 1x0, we have to configure IP NAT outside. Here. Okay. Then to configure static NAT, the command is IP NAT inside source static, then the inside local address, that is 192.168.1.1, then the inside global address, the public address in which you want to translate this address, which is 200.0.0.5. Enter. That is it. It will be configured. So now let's verify first by ping. If you ping from the host to the public web server, which is 200.1.1.1, so ping 200.1.1.1, so that's successful. Now on the edge router, you can verify NAT by the command show IP NAT translations. Now you can see here the inside global address is 200.0.0.5, inside local address is 192.168.1.1, and inside global and inside local addresses the same 200.1.1.1. So this is how NAT works. So here, as we want the inside local address, which is 192.168.1.1, to be translated into 200.0.0.5, and this is how it is working. So that is working fine, that means. So there is one more command, show IP NAT statistics, where you can see the statistics, the number of translations, total active translations, the outside interface, the inside interface, the number of hits, the number of misses, expired translations, everything. So this is how NAT works. So we have done the configurations for static NAT and the verifications for static NAT. So for dynamic and PAT, the configurations we will do in the next video. So thank you for listening.